Okay, class, today we are going to learn a little bit more about angle relationships, specifically around situations where parallel lines are cut by a transversal. Okay, so here is our learning objective. So your goal will be to identify the various angle relationships when parallel lines are cut by a transversal. Now, before we start, let's make sure that we all understand what parallel lines are and what a transversal is. So here's an example of a set of parallel lines. These are lines that run in opposite directions and will never intersect each other going into infinity, to the left and to the right. You'll also notice that there are these blue markers here. These blue arrows, these signify that these lines are parallel. Okay, so these are parallel lines, and then a transversal is a line that cuts through the parallel lines at any angle. So here's an example. Okay, so we have line T, okay, that's cutting through line L and line M. Now, when this happens, there are a number of angle relationships that are taking place. So let's walk through these and identify each one. So here's the first angle. We're going to call it angle 1. And what's really interesting is that if you take a look at the opposite angle, right, the opposite angle would also be the vertical angle. That angle is identical to angle 1. So we're going to label that angle 3. Okay, so then if we take a look at other angles, like this section here, and we're going to label this angle 2, we will see that this angle is going to be the same or congruent to this angle, okay, using the vertical angle postulate. So let's go ahead and label that. Okay, so there we are. Angle 2 and angle 4 are congruent or equal to each other, and angle 1 and angle 3 are also equal to each other. But let's take a look at these other angles. How do these angles relate to any of these, if at all? So if we were to take line M and slide it up to line L, look what happens. Because these lines are parallel, we see that the angles are corresponding. Okay? In other words, they're all the same. It's the same set, but further down here. All right? So now that we visually see that, let's identify some consistencies here. Okay, so I took the liberty of labeling the remaining angles, and you will see that angle 5 is the same as angle 1. Okay, if you recall, when I slid this line all the way up, it matched exactly to this angle. So we know that angle 1 and angle 5 are the same. There's a term for that, and that term is corresponding angles. Okay, there we are. Now, we already talked about vertical angles, so we know that angle 1 and angle 3 are vertical angles, 4 and 2 are vertical angles, 5 and 7 are vertical angles, 8 and 6 are also vertical angles. Okay, now, we also know that angle 1 and angle 2 are supplementary angles because they form 180 degrees. There's another term for that, and that is called linear pair. Okay, so angle 1 and angle 2 are linear pair angles, or just linear pair. Okay, there we are. Now, before I move on to the other terms, we need to label certain regions here. So I'm going to specify that this area over here is exterior, as well as this area, and then between the parallel lines are interior. So I'm going to go ahead and label that. Okay, so there we are. This region, again, is the exterior, and that is basically the entire area above line L. And then below line M, this whole region is the exterior. So in between line L and M is the interior region. Okay? Now that we know what those regions are called, we can now identify additional sets of angles. Okay? So for example, angle 1 and angle 8 are considered same side exterior angles. Okay? Same side exterior angles. Okay? There we are. Now, another relationship is that angle 4 and angle 5 are same side interior angles because they are in the interior. Okay, there we are. Now we have two other types of relationships. The first one is angle 1 and angle 7. Okay, these are called alternate exterior angles. Alternate exterior angles. Okay, there we are. And then lastly, we have angle 4 and angle 6. These are called alternate, right? They're alternate because they're on opposite side of the transversal. Interior angles. Alternate interior angles. Okay, and there we are. Here are all the different angle relationships formed when parallel lines are cut by a transversal. Okay, so let's put some numbers to these angles and see if we can figure out how to work with them. Okay, let's start with this angle. Let's suppose that this angle is 100 degrees. Okay, if that's 100 degrees, then we know what this angle degrees is because both these angles are linear pairs or supplementary angles, and we know that angle then is 80 degrees. Okay, now because we know those angles, we will know all the other angles. Okay, so in other words, if this is 100 degrees, we know that the opposite angle, or vertical angle, is also 100 degrees. And we also know this angle because it is a vertical angle to this angle. So we know that this is 80 degrees. Okay, and because we know this angle is 100 degrees, we also know this angle because it is a corresponding angle. So we can label this 100 degrees. And then we also know what this angle is, okay? Because not only is it a corresponding angle to this angle, but it is also a supplementary angle to this angle. Okay, so we know then that this is 80 degrees. And then likewise, we also know this angle because it is a vertical angle to this angle, and it is also a same side, I'm sorry, not same side, but a corresponding angle to this angle. So we know this is 80 degrees. And then lastly, we know this angle because it is a vertical angle to this angle, and it is also a corresponding angle to this angle. Okay, so this is 100 degrees. Okay, now note that these angles, we know that they're the same, and we also learn the terminology for these angles, and these are called alternate interior angles, okay? They're alternate because they're on opposite sides of this transversal, and you notice that those degrees are the same, okay? Similarly, this angle and this angle are called alternate exterior angles, okay? They are on the exterior of the parallel line, so below the parallel line and above the parallel line, and they're on opposite sides of the transversal. Okay, so these are called alternate exterior angles. Now, what's interesting is that same side interior angles, so it would be this angle and this angle, okay, because it's on the interior and it's on the same side of the transversal, same side interior angles are equal to 180 degrees, or they are linear pairs, okay? They are supplementary angles. Similarly, same side exterior angles, which are these, okay? Exterior, exterior, and it's on the same side of the transversal. On the left side here, they are also linear pairs. They form supplementary angles, which are 180 degrees. Okay, I hope this example was helpful in helping you to understand the various relationships between these angles when parallel lines are cut by a transversal. If any of this was confusing or if you need further clarification, please go back to the beginning of this recording and listen to this again. Thank you.